simplify the first problem, you want to first factor out this as much as you can. So notice 6 times 6 is 36. We know that's already a perfect square. And then everything that's doubled up under the radical can be taken out as one pair. So I kind of like to think of it as socks, because you have a left pair and a left and a right sock. But when you put them together, it makes a pair. Okay, so this pair comes out. We have a pair of 6s. Then we have a pair of z's. And then a pair of another z. Okay, so the square root is square root of z squared is just z. Alright, so when you do that, you actually get 6z to the third. Alright, now a quicker way to do that would be if we think of this as we know the square root of 36 is 6, and then we can call this z to the 6 over 2, because a fractional exponent is the same thing as writing it this way. Alright, so you would get 6z to the third. So those are two ways there you can do that question. Same idea with this one, except now we have a cube root. Alright, so 4 times 4 times 4 is going to give you 64, because 16 times 4 gives you that 64. Okay, so then we have y to the 9th. Now I'm not going to waste time writing that out, because we're just going to use our trick from the last one. Alright, so now if I have things repeating 3 times, I can pull it out and make it 1. And then I can rewrite my y as a fractional exponent. The exponent on the inside goes on top, and the one on the outside goes on the bottom. So I get 4y cubed, and that's my answer. The goal of questions like question number 3 is to get the same number under the radical. So I'm going to start by looking at the fact that the square root of 5 is as simplified as it could possibly be. Now I could do 9 times 5 to get 45, and I know 9 is a perfect square. Okay, same thing here. 4 times 5 is 20. 4 is a perfect square. So I am getting the 5 that I am hoping to get. So now I just need to simplify it. Alright, so 14 root 5 stays how it is. I'm going to get 2 times the square root of 9 is 3 root 5 minus, okay, the square root of 4 is 2 root 5. So when I go to do this, I get 14 root 5 plus 6 root 5 minus 2 root 5, which is then just 14 plus 6 minus 2 times root 5, because basically I can factor out the root 5 because they all have that same factor. So then I just get 18 root 5, and then I'm finished. For questions like question number 4, you're going to look at the bottom of the fraction, and to simplify that, you're going to basically multiply it by that number, or whatever that expression is, over itself. Alright, so when you do that, you get the square root of 10. Why? Because you can multiply them when they're both under the square root like that. Over, and then the square root of 2y times the square root of 2y, just the square root of 2y squared, which ends up canceling out. And that is as far as you can take that. Alright, this question says to multiply. So we're just going to distribute. Alright, so we get the root 6 times root 2 minus root 6 times 2 root 7 Of course, you can only multiply the ones that have the like square root in them. Okay, so we get the square root of 12 minus 2 times the square root of 42. Okay, we can simplify that to 3 times 4 minus 2 times the square root of, let's see, see, 4 won't go into it. Let's just break this down. I don't think this one can go down any further. No. So that's as far as that one can go, as far as square roots go. Alright, so we get the square root 2 root 3 minus 2 times the square root of 42. And that's as far as it can go because there's nothing here that we can take the square of and take out. For this one, you're going to be multiplying and using your FOIL method. Okay, so you do your first, which is 1 times 2, which is 2. You do your inner, your first, your outside. Okay, so that's going to be plus 5 root 6 inside plus 6 root 3 and then your last. So that's going to be plus 15 times the square root of 18. Okay, so then we can see if we can simplify this at all anymore. So this one is as far as it will go. So is this one. Yep. And then this one we could do something with because we have a 9 within here. So 2 plus 5 root 6 plus 6 root 3 plus 15 times 3. The square root of 9 is 3. That's brought out. Root 2. So we get 2 plus 5 root 6 plus 6 root 3 plus 45 root 2. And that's all we can do. Okay, this says to solve for w where w is a real number. So we're going to start by adding 2 to both sides. We're going to get 3 is equal to the square root of 3w minus 15. We then square both sides because you're trying to get rid of the radical. So 9, excuse me, is going to equal 3w minus 15. Then we add. Alright, so it's going to be 24, so w can equal 8. Alright, this one looks a little complicated. It says, suppose a pendulum is L meters long. The time t in seconds that it takes to swing back and forth once is given by t equals 2.01 or 2 1/100 times the square root of the length. If a pendulum is 8.41 or 8 41/100 meters long, how long does it take to swing back and forth once? Really all you're doing is plugging this in and then solving it. Okay, and more than likely it will give you a calculator to help you with that. Okay, so it does say round to the nearest tenth, so t is approximately equal to 5.8, and that's going to be seconds. All right, number 9, solve for u where u is a real number. Okay, so again, if you have a square root, you're going to square both sides. So u is going to be whatever you get when you subtract 36 by 8. So you would get 28 for that one. All right, using the quadratic formula. The quadratic formula is the opposite of b plus and minus the square root of b squared minus 4ac over 2a. Okay, when you have it, this is going to be in standard form. So a is going to be the coefficient of the x squared term, b is the coefficient of the x term, and c is the number that's a constant. So a is going to be 6, b is going to be a -9. Don't forget that negative if there is one. And c is going to be 1. All right, so we're just going to plug this in. The opposite of b would be +9 plus and minus the square root of -9 squared minus 4 times a, which was 6, times c, which is 1, all over 2a. Oops, which is just 2 times 1, or 2 times 6. All right, so you would work that out and simplify it. All right, so in this next step, I've simplified it. So I'm going to keep working on simplifying. All right, so there is nothing that I can simplify under the square root sign to bring anything out, because there are no perfect square factors in 57. And 57 is also not a perfect square. So all I need to do now is simplify each part. Okay, and that's as far as it can go.